Hello there, calculus students, and today on this video we're going to be talking about differential equations, and I have a definition here of what a differential equation is. The first definition we should definitely cover is what is a differential equation. A differential equation is any equation which contains derivatives, either ordinary derivatives, which we're going to be dealing with, or partial derivatives. Partial derivatives are something you would deal with in a more advanced calculus class, maybe in college, but we're dealing with just the ordinary derivatives. Now we'll talk about the order necessarily of differential equations, and that order is just the largest derivative present in a differential equation, and you'll see that. We'll see things that are first order, second order, third order differential equations, and that's probably as far as we'll go, and you'll see that when we get to PVA type of problems later on. So now that you know what a differential equation is, let's look at an example. This is a differential equation because it has a derivative and some other things present, our x squared. And we need to solve this differential equation. Well, we have to use what we just learned, integrals or anti-differentiation, in order to solve this differential equation. This, remember, just means this is the derivative. The derivative of some function y, or f of x, is equal to 3x squared minus 1. And what we're trying to find is, what is y? So how we do that is we, first off, multiply both sides by this dx over here. And we're left with dy equals 3x squared minus 1 dx. Now, in order to get rid of the dy, we have to take the antiderivative of both sides. Remember our integral symbol, our anti-differentiation symbol? When I take the antiderivative of dy, I get y. And take a moment and see if you can't find the antiderivative of this all by yourself from what we've learned in our previous videos and in class. You should have found, by using the power rule of anti-differentiation, we add 1 to this exponent and divide by the new exponent, so it becomes x cubed. This is a number, so if you think about this is a constant, it would become negative x. And then we can't forget our constant of integration, c. This is our solution of our differential equation. This is known specifically as a general solution. And you'll see on the next slide the difference between a general solution and a particular solution, and how we would find a particular solution. So this is a general solution for this differential equation. So now let's look at what the difference is between a general solution and a particular solution. The general solution to a differential equation is the most general form that the solution can take and doesn't take any initial conditions into account. The actual, or in our case that we'll hear talk about, our particular solution of a differential equation, or to a differential equation, is the specific solution that not only satisfies the differential equation, but also satisfies the given initial condition. And you'll see in a moment of what I mean by an initial condition. We're going to take a look at that same exact differential equation, dy dx equals 3x squared minus 1. But this time I'm going to give an initial condition saying y of 1 equals 2. This is our x value, and this is our value when evaluate that x value of y. Okay, so you can think of this the point 1 comma 2, if you will. Well, we've already gone through, and I won't do it again, finding the solution, the general solution of the differential equation, and we found that it was x cubed minus x plus c. Well, in order to find the actual or particular solution to this given specific condition, this initial condition, we have to now substitute in 1 for x and 2 in for y and solve for c. So let's see what happens when we get that. One cubed minus 1. In this case, we get a c value of 2. So in order to write the particular solution, we need to write it with our c value, x cubed minus x plus 2. So this is now the particular solution to this differential equation with this initial condition. What does that mean? That means this is the derivative of this function going through this point. And this is our particular solution. Let's look at another one. Oh, I'm going to change it up a little bit. Have a white background. We have the differential equation dy dx equals 2x to the negative 4 with an initial condition of y of 2 equal to 4. Solving this differential equation, go ahead and take a moment and try to do this one on your own and see if you can actually do it. It's not a difficult antiderivative, our initial condition, and then come back and check and see, did you understand what we did in our last example and can you replicate it? You will see that I take the antiderivative, multiplying both sides by dx, and then I'm taking the antiderivative of the left side, which is just dy that's left, and the antiderivative of 2x to the negative 4 dx. The antiderivative of dy is simply y, and the antiderivative of 2x to the negative 4, you add 1 to the exponent, divide by the new exponent, and we get 2x to the negative 3 all over negative 3 plus c as our general solution. Now we are going to put our initial condition in, y of 2 equal to 4 being our initial condition or our specific condition, and find our particular solution. So I'm substituting in 2 in for x and 4 into y and solving for c. And when we do this, you should see that we end up with 2 over negative 3, 2 cubed. So 2 over, and in the denominator, negative 3 times 2 cubed plus c. I'm going to draw a little arrow up here just so I can finish my math. So 4 equals, or my arithmetic. 2 times 2 is 4, 2 4s are 8. This ends up becoming 2 over negative 24, or negative 1/12 plus c. And then I add 1/12 to both sides. Well, in order to do this, I need to turn this into 48/12 minus 1/12 plus c. And we end up getting c equals 49/12 as our c value, our constant of integration. So our particular solution would look like the following on the next slide. Y equals negative 2 over x cubed, 3x cubed, plus 49/12 is our particular solution. So again, in this video, you learned about what a differential equation is, what the order of a differential equation is, how to solve a differential equation to find a general solution and a particular solution. Hope you enjoyed this video, and in our next video, we will talk about some higher order differential equations, like a order of 2, and maybe even beyond. Johnstone out.